Hey guys, how's it going? This is Siri and I'm back with another PyTorch video, and in this video we're going to be talking about an important operation on tensors, and this one is called transposing. Okay, and it's sort of built off, and the no copying part, which I have here, is sort of built off of the storage module that I talked about in my storage instances video and how PyTorch tensors are stored. So if you're not too familiar with that, I would recommend checking that video out and hopping back on this video, to learn about transposing and how we do it. Okay, so transposing, and there's no copying here. Okay, first of all, this might not make sense if you don't know what transposing is. So, you know how, like, basically everything in machine learning and deep learning is based on matrix transformations, or like tensor transformations, right? It's a matrix if it's 2D, and if it's like 3D or higher, if it's like, if it has 3 dimensions or higher. And remember, tensors are just multi-dimensional arrays, and so you would call them tensors. And an important operation is transposing. And what transposing is that if you have, I'm just going to talk about matrices because we can actually, visualize them. The same applies for tensors as well, though. If we have a matrix, okay, and we, take it by the diagonal, and we draw a diagonal from the top corner all the way down, and if it's not, if it's not a perfect, like, square, then you're probably not gonna get to the end, like, get to the other corner. But whatever, that doesn't matter. You just draw a diagonal, and you rotate it. So what this basically is you're, for matrix, for 2D matrix, you just, like, rotate it. That's basically it. Same values, except, the dimensions get shifted a little bit, okay? And if it's for higher dimensions, then you're not just going to be dealing with these 2 dimensions and you rotate it. What you have to do is you have to specify which dimensions you want to be, swapping, and yeah. So let's talk about that. So what you're basically doing is just you're making the rows columns and you're making the columns rows. That's another way to phrase it. So let's take a look at a tensor. Let's call it tensor 1, and let's say it's a tensor, and it's it has 3 arrays within it. So maybe like 1.0, 2.0, and 3.0, 4.0, and 5.0, 6.0. Okay? And let's print out tensor 1. Okay? And yeah, let's print out tensor 1. So when you print it, you get what you expect, right? Like the 1, 2, 3, 4, 5, 6. Okay, so perhaps, let's assume that, one operation inside this mathematical web, which we call a neural network, one of those operations is to, turn it. What do we do? Well, let's say tensor transpose, is equal to, tensor 1 dot t. And what this t is, this t is a shorthand, okay? If this were like 3-dimensional or higher, then you would have to actually use transpose. But, and the reason is because you don't need to specify which dimensions you need to do this along, because there are only 2. There's only 2 things that you can swap, right? So it's useless. You don't need to pass anything in. And so let's just write that down. Dot .t is a shorthand for dot transform. Okay, so that's what transpose. Why do I keep? Okay, transpose. Okay, so yeah. Okay, and now when we print tensor transpose, tensor 1. Okay, we get, what do we get? We get 135, 246. What the heck happened? Well, like I said, the columns became rows and the rows became columns. Okay, so this column here, 135, became the row, 135, 246, 246. That's what happened here. Okay, so transpose. Okay, great. So let's check something out. You remember I said no copying, right? What does that mean? Well, if you take a look at the ID of the tensor1.storage and we check if it's equal to the ID of tensor transpose.storage, we get true. Okay, I'm just gonna check something out. Don't freak out if it doesn't work, because I don't. Yeah, it's true. Okay, great. So yeah, so it's the same storage. What does that mean? Well, if you recall from our previous storage instances video, you know, these different tensors, even though they have different dimensions, the values inside them are the same, and the values inside are the same, and you know, you can visualize that as part of the long train of values in your storage instance. And the only difference is that the size, offset, and stride are different between the two. So if you take a look at tensor1.stride, okay, let's print that. And if you take a look at tensor transpose, dot stride, you get 2, 1, and 1, 2. So the strides are different. Let's do the same thing here. Size. Pretty sure it's storage size. Or actually, instead of the size, let's check out the offset. Okay, it's the same, because they both start with, they both start with 1. But if you're confused on size, offset, and stride, then I would definitely recommend checking out my my storage instances video on how tensors are stored. Okay. So let's check out the same example, basically, except, with higher dimensions. So, it's not the same, but let's say that t is equal to torch.tensor, actually torch.ones. So this is a factory method. This creates a tensor full of ones with dimensions that you specify as your arguments. And so 3, 4, 5. And we say transpose t is equal to, this t dot transpose. And which dimensions do we want this along? Let's say 0 and 2. What does this mean? What are we actually doing here? Well, when we print it out, we'll see. Okay, so what we're essentially doing is that we're swapping the two dimensions. We're swapping the values of these dimensions along the specified index value. So this is 0, this is 2, right? So let's print out t. And let's have a few lines. And let's print out transpose t. Okay, so what do we get? Okay, so it's easier to see because they're all ones. If they weren't, then we would have to go picking through the values and seeing how they're related. But you see this 3, 4, 5. This is the original one we created. So we have 3 of these rows, basically, because if you assume that this is a row, this is a row, and this is a row, you have 3 of them. You have 4 rows within each one, and you have 5 columns. Okay? So that's what's going on here. What's going on with transpose t? What did we say? We said that they would swap, right? So so we have 4. The only thing that stays the same is the 1. What's the 1? The 1's the 4. The first dimension is 4. So you have 4 rows in each one. Is that the same? Yes, it is the same. But what got swapped? The 0 and the 2. Right? That's, so see the 0. So now originally we had 3 of these rows. Now we have 4. Now we have 5, because that's what okay, see 1, 2, 3, 4, 5. And instead of 5 columns, we have 3 columns. Okay, yeah, so let's check out this. Okay, so does it work if it doesn't, it only, yeah, okay. Yeah, so 3, 4, okay, I think this is kind of hard to look through, but you have to pass in 2 arguments, which are the dimensions you want to swap, so that's basically it. Let's just keep it a little simpler. So you see that the dot t is shorthand. If you do dot t with something that isn't just 2 dimensions, right? We specified 3 dimensions. So if you do dot t, it's not gonna work, because dot t is only, it doesn't, first of all, dot t doesn't take in any arguments, and like, it's only for matrices. Okay, so let's take a look at each of these storages. So t dot storage and id of t dot storage, is that equal to the id of t transpose? Is that what I named it? Oh, transpose t. Dot storage. True. Okay, so yeah, they're the same storage instance, and yeah, that's what I mean by no copying. Okay, and once again, like I mentioned in my other video, this storage that I'm talking about is only on the CPU, which is the computer processing unit. Okay, great. I hope you learned something new today about transposing and about tensor operations with a heavy emphasis on the storage aspect of it. And yeah, I'm looking forward to seeing you guys in my next video. Don't forget to like, comment, and subscribe.